So a ball is thrown at 15 meter per second at an elevation of 50 degree. We need to find the angle of direction after 1/4 second. 1/4 second. So initial angle is 50 degree and the velocity is 15 meter per second. So to find the angle of elevation, first we need to find what is the vertical component of the velocity after 1/4 second. So if we say v after 1/4 second, we can say the initial v is v sine alpha minus gt will be the less amount of v vertical component basically. So this is 15 sine 50 degree and then 9.8 times 1/4. This gives us 9.04 meter per second. So this is the vertical component, and the horizontal component of the velocity, which stays the same throughout, is this much v cos alpha, which is 15 cos 50 degree, which is 9.64 meter per second. So these are the velocities at time is equal to 1/4 second. So t is equal to 1/4 second. So the angle will be, if we say theta, 9.0 for the vertical component of the velocity divided by the horizontal component of the velocity. So that will be 9.04 over 9.64. So inverse will be 43.3 degree. So that's the angle of elevation, angle of elevation after 1/4 second, and that's the angle it makes with the horizontal basically. And when the second part of the question is, when will it descend at an angle of 30 degree to the horizontal? So if we think of the flight path, it looks like that. Initially the angle was 50 degree. After 1/4 second it is 43.3 degree, and the question is, when will the angle be 30 degree while the ball is descending? So it will be 30 degrees somewhere here, but we need to find when it will be here. So this one. So what I will do, we will first try to find when the angle will be 30 degree here, and we will try to find when the angle will be 0 degree, or when is the maximum height. When angle will be 0 degree, vertical component of the velocity will be 0. So that we will try to find, and then we will add this much from here. I will add this much to get this much. So basically this pattern will be symmetrical. So whatever the interval between the 30 degree here to 0 degree here will be the same interval from 0 to 30 degree. It will be the same while going up, while going down, it will be the same amount of time basically. And from each corresponding angle, the time from one corresponding angle to the other will be the same while going up, while going down. So first we try to find when angle is 30 degree, what is the velocity, vertical component of the velocity. So tan 30 degree will give us, horizontal component is 9.64. What is the vertical component? So that will be, that is 5.56 meter per second. From this information we can find the time it takes to reach there. So that will be, we will find that later. We can find that now actually. So that will be 5.56, and initially the vertical component of the velocity is 15 sine 50 degree minus g, and now we need to find the time. So that will be, solving this one, we get t is equal to 0.606 seconds, or let's say just 0.6 seconds. So now we know how long it takes to reach here. Now we need to know how long it takes to reach here when the height is maximum. So when the height is maximum, the vertical component of the velocity is 0. So initial 1, and then, so that's the maximum height when it reaches the maximum height. So from here we get 15, which is 11.5. This one is 11.5 divided by 9.8, so we get 1.17 seconds. So that is the time it takes to reach here, which is 1.17 seconds. Now we know that to reach 30-degree elevation here, it takes 0.6 seconds. So now we can find how much time it takes from 30-degree to 0-degree, this much. So if I use a different color, it will be this much. That will be 1.17 minus 0.6, that is 0.57 seconds. So we need to find when the ball will be ascending at a 30-degree angle. Sorry, descending, not ascending. So when it will be coming down. So from ascending 30-degree to 0-degree, it takes 0.57. From 0-degree to descending 30-degree, also it will take the same amount, 0.57 seconds. It will be the same amount. So this total time will be 1.17, which is the time that it takes to reach the maximum height, plus this much, which will be 0.57. So that will be 1.74 seconds. 1.74 seconds basically.